So we've kind of learned this piece by piece, but what I want to do is I want to take what we learned last week and this week and put it all together to make a probability model and use that to find the expected value and standard deviation. So here's our question. We are the manager of a computer company, or managers, I guess, if it's plural. We sold 2 computers to a client and randomly grabbed 2 computers from a stack of 15 in the storeroom. However, we recently learned that one of your employees stuck 4 broken computers back in the storeroom, so only 11 out of those 15 work properly. If your client gets 2 good computers, then that's fantastic. We're not going to lose any money. We're just going to get whatever money we had before. If your client gets 1 bad computer, he or she is not going to be very excited. You're going to give him or her $100 to soften the blow a little bit, as well as the working computer. But if your client gets 2 bad computers, they're just going to be done with you and cancel the order, and you're going to lose $1,000. So create a probability model. Before we can do that, we have to first look at the probability calculations. So one way to look at that is to make a tree. So think of this as 2 events happening. The first event is you gave them a computer. And so that means 11 out of 15 work and 4 out of 15 were broken. So we're assuming the top branch said the first one we gave them worked. The bottom branch said the first one we gave them was broken. Then we're using that conditional probability that says, okay, I already took 1 computer out, and so on the top I'm going to take, I have already had 11 that worked, now there's only 10 because I've already given the client 1, so now on the top I'm going to have 10 out of 14 working computers, and then 4 still that were broken out of 14. For the broken, again, we're assuming the first one was broken, so there are still 11 that work out of 14 left. And for broken, I already took a broken one, and so now that's 2 broken ones. So again, I'm just going to look at the probability by multiplying, and notice what I did is I looked at those probabilities as fractions so that I didn't have to round in the middle. So then I took 11/15 times 10/14, and then I turned that into a decimal. And then I took 11/15 times 4/14 and turned that into a decimal, and I continued. Now, if you'll notice, my outcome is that the person gets 2 working computers. And I've grouped these together, and the reason for that is they either got a working and a broken, or a broken and a working, but that's still the same outcome of losing $100. And then on the very last branch, broken times broken gives me the probability that I'm losing $1,000. So that's the tree to help me with the probabilities, and then I have to make a probability model. So this is the probability model, and that model shows the negative $1,000 and then the probability that I lost $1,000, which was 2 broken, and then shows me negative $100, which is anything here in the middle, which was 0.419, and then it shows me that I didn't lose any additional money, which is 0.524. So that's the probability model. So now that I have my probability model, I'm going to use StatCrunch to find the mean, or expected value, and the standard deviation the same way I did before. So notice all I've done here is I've put my outcomes, negative 1,000, negative 100, and 0, into the X column, and in the probabilities, I've copied the probabilities that I found from my tree. So to find the solution, Stat Calculators Custom, the values are in X, the weights are in the probability that X equals X, and I compute, and I end up with a mean of negative 89.9 and a standard deviation of 226.74, rounded to the nearest cent, which is what would make sense in this question. So we expect the mistake to cost us $98.90. So notice I didn't include the negative because in my words I said it's going to cost us $98.90, and the standard deviation is 226.74, and that should make a lot of sense because there's kind of a large spread. So notice what our graph looks like here. Our graph shows us the probability of losing $1,000, the probability of losing $100, and the probability of not losing any additional money. And so we can see that there's quite a bit of spread between the negative 1,000 and the 0. So let's see if we can put this all together. I have a 6-sided die and an 8-sided die. And the 6-sided die has 2 3s, 3 1s, and a 2. So that's 6 total sides. And the 8-sided die has 5 2s and 3 1s. So that's 8 total sides. And I want to find the probability model for the sums. And then in a moment, then we'll take that probability model and find the expected value and standard deviation. So at this point, I'd like you to press pause and try this question from start to finish. And then we will go through each part together. So the first thing I want to do is, again, maybe make a tree diagram would be helpful, because on my first event, which is rolling the 6-sided die, I'm going to either get a 3 or a 1 or a 2, and those probabilities are all different because there's 2 3s, so that's 2 out of 6, there's 3 1s, so that's 3 out of 6, and there's 1 2, which is 1 out of 6. And so notice what I've done, a sort of a little neater than this, is said, okay, I could get a 1 or a 2 or a 3, and so that was my outcomes, 1, 2, or 3. And the probabilities were 3/6 for 1, which is the same thing I had here. I just put it in different order. 1/6 for 2, and 2/6 for a 3, and notice that's exactly what I have at the bottom. My second event is rolling the 8-sided die, and so the 8-sided die has 5 2s and 3 1s, so notice an outcome of 1 is 3/8, an outcome of 2 is 5/8, and I just repeated that. I copied and pasted off of each of those other values. And what I'm interested in here is not only the probability like we normally would look for in a tree diagram, but also what is the sum, because there's only a certain number of sums that I could get. And so here, if I had 1 plus 1, the sum is 2, and the probability was 3/6 times 3/8, which gave me that decimal. And I continued that process and noticed that my only possible sums were 2, 3, 4, or 5. So what I did then is take all of that information and just organize it a little bit better. My possible outcomes are 2, 3, 4, or 5 as a sum. Those probabilities are the 0.1875, and then there were 2 different ways to get a sum of 3, and that added to the 0.375 I put here, and 2 different ways to get a 4, and so I added those together, and then how to get a 5. So that is my probability model, and from there I now want to look at what is the expected value and standard deviation based on that model. So all I've done now is copy that probability model just by typing it into StatCrunch. So I've typed it all in by hand, and now I want to use StatCrunch to find the expected value and the standard deviation. So I'm going to go to Stat, Calculators Custom. My values are in X, my weights are in the probability column, and Compute. And again, I've got a mean of 3.4583 and a standard deviation of 1.019738. And if I were doing this for an assessment, which you will have to do, I would basically make sure that it all fit on the same screen so I could see your probability model fully and your mean and standard deviation that StatCrunch has calculated. And then I would just take a screenshot of that area.